Dear student, today is the second presentation of our chapter Trigonometric relation. So let's start by trigonometric relation on the same acute angle. For this, take a right triangle ABC and fix the angle B by x. Then the sine of x and the cosine of this angle x are between 0 and 1. This is the first rule. Second rule is the most important rule, since it's the most used in trigonometry. It is that sine square of x plus cosine square of x is equal to 1. And be careful about the square. It's not sine x plus cosine x equal 1. And third rule is that tangent of x is equal to sine x over cosine x. Let's prove this identity. First, let's start by this rule. We need to prove that sine x is between 0 and 1. We know that sine x is equal to the upper side AC over the hypotenuse. And these two sides are positive, then the ratio is also positive, so sine x positive. Since BC is the hypotenuse of this right triangle, then AC less than BC, so sine x is less than 1. Same proof of cosine x. Cosine x is equal to the adjacent side AB of the angle x over the hypotenuse, and these two sides also are positive, then cosine x positive. And we know that BC is the hypotenuse, then AB less than BC, so the ratio is less than 1, so cosine x less than 1. Sine square x plus cosine square x is equal to 1. Replace sine x by its values AC over BC and cosine x by its values AB over BC. So, AC over BC squared plus AB over BC squared is equal to AC square over BC square plus AB square over BC square by same denominator BC square. The result is AC square plus AB square. We know that the triangle is right at A, so according to Pythagoras theorem, AC square plus AB square is equal to BC square. Simplify BC square and BC square, then it's equal to 1. Third rule is that tangent of x is equal to sine x over cosine x. We know that tangent of x is equal to the opposite side over the adjacent. Let's start by the second part of this identity, sine x over cosine x, and replace the sine and the cosine by their rules. Sine of x is equal to AC over BC and cosine of x is equal to AB over BC. Simplify BC and BC, then we get AC over AB, it's tangent of x. Application 4. Let alpha be an acute angle such that sine alpha is equal to 0.5. The question is to find cosine alpha and tangent alpha. Apply the second rule, sine square alpha plus cosine square alpha is equal to 1. We need to find cosine, then cosine square alpha is equal to 1 minus sine square alpha. Replace sine alpha by its value 0.5 and we get cosine square alpha is equal to 0.75. Then cosine alpha is equal to radical 0.75 or cosine alpha equal minus radical 0.75. But we know that cosine alpha is positive, then the second answer is rejected. So my answer is cosine alpha is equal to radical 3 over 2. Apply the rule of tangent alpha is equal to sine alpha over cosine alpha and replace sine and cosine by their values. We get tangent alpha equal radical 3. Application 5 about complementary angle. What we know about complementary angle is that their sum is equal to 90. For this, consider ABC a right triangle at A and fix the angle ABC as alpha and the angle ACB as beta as shown in the figure. The question is to show that sine alpha is equal to cosine beta and tangent alpha is equal to 1 over tangent beta. Let's find sine alpha. We know that sine alpha is equal to the opposite side over the hypotenuse. Then sine alpha is equal to AC over BC. And cosine beta is equal to the adjacent side of the angle beta over the hypotenuse. So cosine beta is equal to AC over BC. And we see that these two ratios are equal, then sine alpha is equal to cosine beta. Let's prove the second identity, that tangent alpha is equal 1 over tangent beta. We know that tangent alpha is equal to the opposite side over the adjacent. So tangent alpha is equal to AC over AB. And let's find 1 over tangent beta. It's equal to 1 over tangent beta. It's also equal to the opposite side over the adjacent, then 1 over AB over AC. So it's equal to AC over AB, and we get the same ratio. Then tangent alpha is equal to 1 over tangent beta. Conclusion. If alpha and beta are two complementary angles, then sine alpha is equal to sine beta, and cosine beta is equal to sine alpha. And tangent of alpha is equal 1 over tangent beta.